Okay, probably one of the most important concepts in rate is electrical rate, because that's the number one thing that probably we use as much as anything. Electricity is such a fact of our life. Electrical rate is how fast, maybe how fast is not the correct word, how many electrons flow in 1 second. And it's probably one of the most important things out of electricity that you can get, and that is electric current. Now, quick review again, current can be either AC or DC. Wall sockets, AC. Batteries, solar panels are DC. Now, current in equation-wise is denoted with the letter I. So we're going to use I for current. You've already measured it in a number of labs, and you will continue to measure it in more labs. And it's equal to Q divided by T, which is charge per second. Now, the good thing about electrical rate, about current, is the fact that there is no SI or metric unit that's any different than the English unit. It's the same unit. It's an ampere. 1 coulomb per second, so we'll go units. 1 coulomb per second is equal to 1 amp, named after ampere, but we usually 1 amp, or sometimes you'll see it written as just 1A. We don't usually say the entire term ampere, but you can if you want. You're not wrong to say it. So you could easily have, if I is equal to 3 amps, how much charge is delivered in 60 seconds. Okay, that's the type of sample problem you can easily have with this. Well, we know that I is equal to Q over T. I'm looking for Q, though. I'm looking for charge. So therefore I have to do a little algebra. You can also use the circle. Remember, you have Q over T, so in the equation you're going to put Q over T, and then I goes here. Since you're looking for Q, if you cover Q up, it tells you that Q is equal to I times T. Now here's where you have to be a little bit careful. Well, in this case you don't have to be careful. They can oftentimes give you this in minutes, and then you're going to have to convert it to seconds. So I'm going to take 3 amps times 60 seconds. Now, 3 times that is 180. Now, an amp is a coulomb per second. So if I multiply coulombs per second times seconds, the seconds cancel out. I have an answer of 180 coulombs. That tells you how much charge has been delivered. Remember, 1 coulomb is equal to 6.25 times 10 to the 18th electrons. Electrons are tiny, so therefore it takes a lot of them to move. Now, while we're talking about electric rate, let's also review over oscilloscopes. We've been playing with them a little bit on the computer. Oscilloscopes actually measure voltage versus time. So the graph you get on your thing is actually going to measure voltage on this side and time across the bottom. Oscilloscopes are usually very good to study waves. They're also good to study electrical signals. And that's probably the 2 places we most commonly use them. In electrical signals, a couple of the common ones we've already talked about: EKGs, EEGs, waves, a lot of sound stuff. Whenever you look at soundboards and stuff like that, and you see things bouncing all over the place, that's actually telling you it's an oscilloscope reading of what it is. I use the talk to text feature on my phone all the time, and it will show you the waves that you are creating as you talk, as they're recorded. So oscilloscopes, realize you on this side you have a volts per division button that helps you. On this one you have a time per division button that helps you. So oscilloscopes again are used to measure sound and waves and signals. So electrical rate. Real quick review. Electrical rate, I is the variable, A is the unit, but again, that's a coulomb per second, so that will help you. Equation-wise, I is equal to Q over T. Remember, you don't have to memorize equations, you just have to be able to use them. So electrical rate simply tells you how fast electricity is flowing, tells you how much is flowing. Electricity has three parts to it: voltage, current, and resistance. Resistance is one of the next things we will talk about. So that will help you. Okay, hope this helped.